make the two computers communicate with each other, we need a network. Difference in mode of operation of the central processing unit as well as the peripheral devices. CPU is going to handle the data will be very much different from how does the I/O devices handle those data. It is communicating only with the interfaces, not the actual components. Hello students, welcome to the next session of Digital Electronics. I am Dr. Soumeshri from Department of Computer Science, Vidhyaashram, First Grade College. In this session, I am going to tell you something about the organization in input-output device. How does the input-output devices are connected? How they are going to give the input and get the output from the processor. Let's start this session. First thing is the input-output organization of the computer depends upon the size of the computer and the peripherals connected to it. So, that means input-output cannot work independently. They depend on the size of the computer. Size of the computer is not the size of the monitor or the keyboard or the processor. Size of the computer is size of the memory, how much memory you have, how much speed is your processor, and other peripherals connected. What is their data transferring speed? Based on that, the speed of the input-output devices will also be decided. Okay, it depends on the speed of the processor and the connected peripherals. All right. Now, the input-output subsystem of the computer provides an efficient mode of communication. It provides an efficient mode of communication between the central system and the outside environment. Like, who is going to interact with the user, end user, or somebody who is not of the computer part is the input and the output devices, isn't it? CPU doesn't interact with the outside world, isn't it? It's only about the components of the computer. But the input device takes the input from the outside world. So maybe end user, for example. So somebody else, an animal cannot do that. A human being can use the keyboard, isn't it? So it accepts the input from the outer world and the output device is going to provide the output or the processed output to the outer world. So the input-output subsystem are meant for the mode of communication between the central system or the processor and the outside environment. Now, we shall look at some of the peripheral devices and their working in the computer. Okay. What is a peripheral device? Peripheral device, which is an external device connected to a I/O module or input-output module. In short, we will call it as I/O, that is input bar output. Okay. So, the external device is connected to an I/O module or input-output module. What is the task of an external device is? It provides a means of exchanging the data. It is going to exchange the data between the external device, some other external components, and the computer. So, the input-output module is connected to the input device and the output device. They have an intermediary or they act as an intermediary between the computer system or computer environment and the external device environment. External device is nothing but here one of the input or the output device. Okay. The external module or the peripheral devices are attached to computer by a link. They are attached to computer as well as to the I/O module with a link. Okay. So, this link is used to exchange the control. It is used to exchange the control. status, how does the data is manipulated, how you can move the data from keyboard to the processor, from processor to the output device, and data between the input-output module and the external device. So, exchange of data between the external device and the input-output module will also be handled by the peripheral devices. Okay, there are three categories of external devices or peripheral devices. One is which is human readable, which is which can be understood by the human. Okay, so this is suitable for communicating with the computer user video display terminals, like we have the keyboards. Human readable form. If it is another output device, some other output device, printer, plotters, all those things will give you a result which is human readable, isn't it? So we have the external device which are categorized. One is human readable, suitable for communicating with the computer user. So computer user, what they use is video display terminals or the printers and plotters, which is human readable form. Another type is machine readable. Human readable, machine readable. Okay. So machine readable peripheral devices or external devices are suitable for communicating with equipment. They are communicating with equipment, not the human beings or the users. The machine readable peripheral devices will communicate with the computer equipments. What are those equipments? Is the magnetic disk, which is used for memory, and tape system. Again, another type of memory. Magnetic disk is one type of memory and the tape system is another type of memory. Along with that, it communicates with sensors and the actuators. So these are the machines or these are the components which are connected using the peripheral devices, and they communicate with these computer equipments or components which can be called as the machine readable form of external devices. The third one is the communication type of peripheral devices. This is related to the network. So this is suitable for communicating with the remote devices. What are those remote devices? To communicate with remote devices such as a terminal, some other monitor placed somewhere else, like connecting the CPU to some monitors. Say if you have functions, you may have viewed the big screens, isn't it? It doesn't have any CPU with it, but they are connected. They are connected through the communication peripheral devices. Okay, so it is suitable for communicating with remote devices such as a terminal. It is the end terminal, a machine readable device which is readable only by the machines like ports and other buses, or another computer. As I said, for networking. Networking is connecting two computers, isn't it? To make the two computers communicate with each other, we need a network. Okay, so that kind of peripheral devices which help in communication between different components of a computer, different computer, are called as the peripheral devices for communication. Okay, so now we have the block diagram of these external or peripheral devices. Okay, so we have the peripheral devices connected, like we have the control unit and logic unit, where control signals comes from the input-output module and status signals will go to input-output module. Status signal is making the input-output systems aware of what is happening in the control units and the ALU. Like if the addition operation is happening in the ALU, the input-output machine will be indicated that when it is moved from memory to ALU, memory will be free. Now the input device will be notified that you can send some more data, the memory is free. That instruction or the status signal will be given by the input-output module. Along with that, for output module, I am sending this result, you have to display this in this format. So this signal will be sent by the input-output module. Now we have the data bits that is transferring from or to input-output module. From input module and to output module. We have the buffer, transducer which communicate with the input-output module. Now we have these data to and from the external environment, which comes from the external environment and is communicated with the I/O module to communicate or to move or transfer the data between different components of the computer. Okay. Now let's know about the input-output interface. Okay. The input-output interface, it provides a method for transferring the information to which it is transferring between the internal storage, that is such as memory and CPU registers. So it helps in transferring the information between the internal storage and the external input-output devices. So we use the input-output interface for that. Next thing is peripherals connected to a computer or input-output interface connected to a computer need special communication links which are connected, peripherals which are connected to the main processor needs a special communication link for interfacing them with the CPU. They need to interface these things with the CPU. Otherwise, there will be no connection between the input device and processor or output device and processor. They are all interconnected to perform a task which I have already explained in the last session, isn't it? How to get a data from the memory, how to perform the arithmetic operation. All this I have explained. To execute these concepts or execute these operations, you need to have a communication link between the peripheral devices and the central processor or simply the processor. They have to be communicated. So this input-output interface acts as a link between the I/O devices and the CPU. Okay. The purpose of communication link is to resolve the difference. What kind of difference is there? What must be resolved? So it is to resolve the difference that exists between the central processor and each peripheral device. There will be difference in mode of operation of the central processing unit as well as the peripheral devices. So you need a communication link which acts as a translator. So the I/O interface acts as a translator. How it is going to act as a translator is, it is going to convert the format that is in I/O devices to the format which is understood by the CPU. And while data is coming from CPU to output device, it again translates the format to the suitable form which is understood by the output interface or the output device. Alright. So working of each of the component is different. How they are working, how they can be enabled, how the data can be transferred, everything is different with different components. To make them communicate, you need a common communication link. So that communication link will be provided by the input-output interface. Okay. So next thing is to know about the major differences. What are the major differences that exist? There are peripherals are electromechanically and electromagnetic devices. They are electromechanical and electromagnetic devices, and their manner of operation or mode of operation of the CPU and memory are different. which are also electronic devices. All are electronic components or devices only. But working mode of the peripherals and the CPU and the input-output, everything is different. Therefore, a conversion of signal values will be needed to communicate between different components of the computer. Along with that, the data transfer rate of the peripheral is little slower or normally slower than the transfer rate of CPU, and you need to have a synchronization mechanism between the peripheral device and the CPU. The speed at which a keyboard sends the data, the speed at which CPU processes it, and the speed at which it reaches the output device, everything differs. Okay, so speed of the processor is very high when compared to the data transfer rate of the input device and the output device. That means it will be slower than the processing speed. Okay, now you need to make the synchronization, that the speed of the devices, the IO devices and the processor needs to be synchronized to make it work properly. For these things, you need a synchronization method to communicate. Therefore, we have the synchronized data transfer mechanism and asynchronous data transfer mechanisms. About that, we shall discuss later. So, there are two types of data transfer methods because of the mismatch in the speed of the execution in the peripheral devices and the CPU. We have two types of data transferring. That is, one is the synchronous data transfer method, another one is the asynchronous data transfer method. Alright. So, there are the data codes and formats in the peripherals which differ from the word format in the CPU. How does the CPU is going to handle the data will be very much different from how does the IO devices handle those data. Okay. So, we have the peripherals that are used. Then we have byte form of data, block type of data, CPU or memory word will be used for communicating with other peripheral components. Okay. Apart from that, the operating modes of the peripherals, the connected devices or the peripherals different from each other. How does the operating mode will be there with the keyboard will be different from that of monitor, because keyboard has a different set of tasks to perform and monitor has different set of monitor to perform, isn't it? When their working mode is different, their operating mode, their structure, their memory space needed, their speed of communication, everything will differ, isn't it? Even though they are interconnected in a computer, the mode of operation or operating mode is different with different components. Okay. So, and must be controlled. They must be controlled so as not to disturb the operation of other peripherals connected to the CPU. There will be ports, there will be so many buses, wires that are connected which are working in parallel with the input and the output device. Sometimes the input device and output device may be in an idle mode, not working until we press a button or do something in a keyboard or in mouse. The input device as well as the output device will be in idle state, isn't it? If you leave the keyboard and the monitor for 10 minutes, it will go to sleep mode. That means they won't work. They'll be in idle mode. But whenever or all the time when the computer is on, the CPU and the peripheral components within the CPU must have to work. Okay. So, the only components that will be in idle state when there is no use are the input and the output devices. So, you need to have a controlling method so that it will not disturb the other connected peripherals which are working along with the processor. Okay. So, these are the major difference between the peripheral devices and the IO devices. Okay. Now, to resolve these differences, what we can do? The computer systems include the special hardware components. They include the special hardware components between the CPU. We include different components between the CPU and peripherals, other peripheral components, to supervise, to look after the changes and synchronizes all input and output transfers. They are meant to synchronize the input and the output transfers. Okay. Then these components are usually called the interface units. We call these units or components as the interface units. Why? Because they interface between the processor and the connected peripheral devices. Okay, so processor bus and the connected peripheral devices, they are going to communicate with them. The input-output interface defines the typical link between the processor and several peripherals. They provide a link between the processor and several peripherals. The input-output bus consists of the data lines, address lines, and the control lines. So they built a data line or bus consists of the various data lines which help in transfer of the data, address line which help in communication of the address, and the control line to control the overall processing of the data within the computer. Okay. Now we look at the various peripheral devices which we have used. So we have the input devices like keyboard, optical input devices like the card reader, paper tape reader, barcode reader, and optical mark reader. Like we'll be having in your CET question papers, there will be optical reader. Then we have the magnetic input devices. They are magnetic stripe reader, like we do in a tape recorder. The cassette we use, we read the magnetic stripe. In the same way, there will be magnetic stripe reader, which is within the CPU. It will not be visible to you. Then we have the screen input devices, that is the touch screen, light pen, and the mouse. Okay. About the output devices, we have output devices, so many output devices too. We have the card puncher. The normal one is the monitor. Then we have the card puncher, paper tape puncher, the CRT, LED monitors, the printer like daisy wheel printer, dot matrix and laser type of printer. Then we have the plotter. These are the some of the output devices and these are the some of the input devices. These are also comes under the category of peripheral devices. Okay. Now we shall look at the I/O bus and its interface, how they are connected. Now we have the processor here, the data bus or data line, address line, and the control line. Okay. Now we can observe that all the interfaces or all the components are connected through control line. Now we have the interfaces for input, input interface, output interface. This is input interface, output interface, and memory related interface. Okay. Now we have the keyboard and display terminal. The address line will communicate with the printer, the output device, input device, as well as the memory device to fetch the address. Okay. So it has to fetch the address of the keyboard or the other input devices. Then we have another interface for connecting or getting the address of the printer so that data will be communicated to printer, isn't it? Then we have the magnetic disk. The address line gets the address of the memory location to store and access from the memory. Okay. Then we have the data line. What does the data line is doing? It is communicating only with the interfaces, not the actual components. It is communicating with only the interfaces. The input interface by the data line, the output interface will be accessed again by the data line, and the memory interface is also accessed by the data line. That means data line communicates with only the interface, not the actual components. But the address line and control line will communicate with the actual components of the computer. Okay, let's know more about these interfaces. We have so many interfaces. The interface decodes the device address or gets the device code or device address. Along with that, it decodes the various operating commands to interact with the components. Then interface also provides signals for the peripheral controller to signal the controlling of the peripheral devices, how it must be controlled. And it synchronizes, interface also synchronizes the data flow and supervises the mode of data flow, the speed of the data flow, how much speed the data is flowing and the mode of data transfer. Everything will be controlled by the interfaces. Then we have the controlling or tracking of the transfer rate between the peripheral device, the CPU or the memory. Everything will be done by the interface in the peripheral devices. We have 4 types of command interface that can be checked. They are control interface, the status related interface, the data output interface and the data input command interface. So every task will be handled and supervised by one of the interface. And is monitored usually by the input-output interface and the memory-related interface. This is all about the input-output interface we usually use in a general computer. All right. Thank you.